Okay, here I'm answering, or I'm going to try to answer question 20 from homework 1. So I copied the sequence and I'm going to paste it here. I'm also going to copy sequence 2. So those two are reads, right? There was a sequencing one, and that's the information received. Now, if I had all the patience in the world and time, I would just compare each letter, but I'm smarter than that. So I'm going to do BLAST2. One thing, if BLAST2 is not working, do not to torture you. Okay, go to the site. It's thinking. So I would never make you compare this. And if I do ask you to compare these things, I'm going to like underline and make different colors just to make it visible to you where they overlap, to see if you understand what do you do with that overlap. But I want to make you stare at these and find where are they the same and where are they different. So I'm going to paste this first sequence here. And the order doesn't really matter. And the answers are keyed that if you switch these, you're still going to get the answer right. But I just like, I like doing things systematically, so that is easy for me to remember what I did. And if something goes wrong, how can I change it? Okay, so I'm trying to go down here to hit blast. And my screen is not allowing me. Is it still loading? No. All right, how about I just hit the enter and see what happens? Hope for the best. No, it's broken. Okay, reload. And let's see if this one showed. Oh, okay, so it apparently finally loaded this one. I'm going to show you guys the answer for that question. No, put it here again. Sequence 2. Sequence 1, and then we're going to read on the news later if there was like some problem with internet and where. Remember that the day like Google wasn't working? Hey, great! Now I have the thing to click. So this is going to run. And then an unrelated question where I created 2 strings, 2 DNA sequences, where I, on purpose, put an inversion in the middle. Here's what I would see. This is not the homework question, it's just something I was doing earlier. See, those are the parts that overlap. And you can see that there's like more chunks because I made a longer sequence, so there will be some parts that just by chance will match. And you're like, oh, I want to make sense more easily about this craziness. Then I go here on the dot plot. And oh, look at that. Apparently I did some duplication. Okay, this came out crazier than I imagined. So here is the part that matches, the other part that matches, the inversion that I created. And then these other guys are actually matches that are less significant. So these lines here are all the other alignments that if you see here, there were more than just 3. I was expecting 3 alignments, right? But these are the 3 main ones. So yes, the one there's a plus plus, the one that's a plus minus, the one that's a plus plus. And then there's these other ones here, which are like smaller chunks that matched. But how do I know they're less significant? The alignment is shorter and the expected value is larger. So I don't remember if I already told you guys, but this is called the E value, and it's the chance that 2 things are going to match just by chance. And so if it's a high number, it means that that's not a very meaningful match. If it's a low number, it's a more meaningful match. Okay, so this was the answer for that question where I entered the same sequence on the top box and the bottom box, but then I inserted an inversion in the middle. Okay, let's see for question 20 if it ran. Hooray, it looks like it ran. All right, on the dot plot, I see where they overlapped when it loads. Okay, to answer that question, don't really need to see the dot plot, but I wanted to show you that there would be a part that's the part where they match, and the diagonal line it represents just the part where they match. It's not the whole sequence. And then the alignment, that's the part where they match. Okay, so if I am using those to build a config, I'm going to ignore this part because this match is not very significant, because I'm trying to build the config, and this is just because it's a short sequence, then they look like each other, right? But what I do know is that from nucleotide 41 to nucleotide 180 on that first sequence 1, it matches nucleotide 316 to 177 of the other one. And that's when they go like, oh, it's plus minus because this number is increasing on the query and the number on the subject is decreasing. So it's a plus minus orientation. So I already know that when I'm going to make my config, I have to reverse complement one of the two strands, and I reverse complement the second strand. So maybe to recap what we did this, because I went back and forth between homework and the other question. I'm doing question 20 from the homework, and I pasted sequence 1 and sequence 2 on BLAST2. And then after a while, it gave me this as answer under alignments, and then the dot plot. All right, so here's where there was the more significant match, and it's a slope down because it's a plus minus orientation. And these little chunks here, they are parts that the two strands do resemble each other, but it doesn't make sense for me to consider these in making my config. You will see how that works. All right. So wait, that was a question. So now I want to see where does this overlap with this. And then what I do, there are different ways. I can do this. I can highlight this. So Control C and see where this sequence is on my sequence 1. So I go here and I'll find, and there you go. Hey, this is where sequence 1 overlaps with sequence 2. So I like making that bold or underlined or bold. So up to here, Control B, Control U. Oh wait, there's one more T that I forgot here. Control B and U. And you're like, okay, how about this and how about this? Well, this is the rest of the alignment. So I'm going to go in here. So all of these align. This is like 100%. 140 of those nucleotides I entered, there's 100% identity. So I know that from that beginning to this end here. So I'm just going to copy that. Then Control F, Control V. Okay, so this is where they match. Control B and U. And then you're wondering, how about this part here? I don't want to assume that they're the same. Then I go, okay, you're being really careful. So go in here, and now it's this part in the middle that I hadn't highlighted yet. So if you remember, I copied this, and then this, and then this. So try. That's the middle part. So, I saw that there was I heard there was a question, and then now let's go see what the question is. No? That was a ping. Let's see. The plus minus, what it means. It means that this sequence here came from one DNA strand, and this sequence here came from the other DNA strand. But when there is a match between that says plus minus, it means that you are looking at the same DNA fragment, but you read one strand in one read, and the other strand on the other read. So when I do the reverse complement, this will be a little bit clearer. So let me show you another evidence that this is plus minus is the fact that this sequence appears in here also, right? Because that's what BLAST told me, that this is where the identities are. But if I do Control C, Control F, Control V, then it says, okay, that sequence occurs here, and it's not like, what the heck? Where is it in here? Like, oh, this sequence exists in here, but only if you're reading the other DNA strand. So remember, DNA is double-stranded, and we read it 5 to 3. So how am I going to find this sequence in here if it's not appearing? And BLAST is telling me that this sequence has that. Then what I needed to do is I do the reverse complement of sequence 2. And this thing here, FASTA format, the computer ignores the stuff that comes after greater than sign, but I write it there for myself just so that I don't get lost. What I'm going to reverse complement this one. All right, so let's open reverse complement. Then I'll clear that, put that there, submit. Okay, so copy that and put it in here. You might be wondering, aren't there programs that do this for you already? And it's yes, there are. But I wanted to show you how it's done when you don't have those programs, and also if you are doing the steps, then it's easier for you to understand how this is coming about. So okay, this thing here is the same sequence as this, but I'm reading the other DNA strand. So when I say the same sequence, I mean you're looking at the same DNA fragment, but you're looking at the other DNA strand. So now I have to find, okay, this part here that the BLAST2 told me. I'm doing a Command C or Control C. I want to see where does this occur in sequence 2. And then I'll do a find and a V. And shows it doesn't occur here. How come? Why is that? Did they copy an extra letter? Let's see. So it starts with TTA. TTA, oh yeah, I copied one extra T. I did this on purpose to show you. I'm kidding. Okay, so TTA, and it ends with GAG. And the other way of doing this is by going by the numbers. Okay, GAG, good. What do I mean by that? You count the 41st nucleotide, and you are not going to count that by hand because that's crazy. You just like highlight some portion, and let's see. This first T should be my 41st nucleotide. So I can go here, tools, word count, and it says 41st. I'm like, hooray, good. Now I'm good. Okay, so which part? Where is this sequence from sequence 1? Okay, I copy. Now I'm going to do find V. Yay! Now it has worked. So this is the part where they overlap. Okay, Control B, Control U. So when you're building your config, if your BLAST2 says this strand orientation is plus minus, then you know that you have to get the reverse complement of either the first or the second, but I'm showing you the easier way, that's the second, because that is the strand that BLAST2 does the reverse complement. So see how it's exactly here and here, and this sequence goes from a higher number to a lower number. That means that the bottom sequence is the one that is flipped, the reverse complement. Okay, finally, the last step. We're almost there. So this is your config, which will be this sequence and this sequence put together. Then you have to see where's the overlap. Overlap is here is in the end, and this one, the overlap is in the beginning. So that means that that DNA strand has this DNA sequence, this DNA sequence, which overlaps with that. So then I'm going to jump to over here. Oftentimes students repeat that. Remember that the part where they overlap is the part between the reads that was the same. Like your sequencing reactions, each of those reads, they read the same chunk of the DNA. And your job here is to find what is the chunk. And then when you're doing your contig, you only represent that chunk once. So I'll show you the right way of doing this. So I'm going to copy this, Control-C, and then Control-V. And then the right way is, okay, this is where the overlap ends. So the new information is actually this part. Control-C, Control-V. And this is the you enter in the exam or in the homework. And it doesn't have to be this first and that second. Maybe I would have made this one sequence 1 and this one sequence 2. What you want is some information that doesn't overlap, an overlap, and some information that doesn't overlap. Got it? And the part that overlaps, you only enter it once. Doesn't matter if you do the blue version. So I could have deleted this, and I copied the green version. Control-C, put it here. Okay, I want to make it the whole thing one string. So that's the same answer. But what I don't want to do is, okay, this, I'm showing you how to do it wrong, which is copy this. Don't do this, but showing because that's the most mistake. Okay, that's some other sequence. So, all right, that, and then that. If you do this, you just created a duplication in DNA because you have this, which is the same as this. And you're like, I don't believe you, that's a duplication. Okay, then put this whole thing on BLAST and BLAST2 and BLAST2 against itself, and then you're going to see those parallel lines.